For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Question that I've got that came in, is there such a thing as junk DNA?
Well, I don't think we know. There seems to be a lot of DNA, which is deoxyribonucleic acid. That's actually the code in every cell of your body. You have about 100 trillion cells in your body. And each cell has 46 chromosomes, except for the gametes, they've got 23. Each of those chromosomes is the DNA, is the deoxyribonucleic acid. It is unbelievably complex. There's more code in each cell of your body than there is in any computer ever built by man. Unbelievable amount of information and code in there, more complex than the space shuttle. Each cell of your body is more complex. But what they oftentimes thought was junk DNA turns out to be a backup system or redundant. So in case some DNA is damaged, X-rays from the sun come down here and they go right through your body. On the way through, they just like getting shot with a machine gun. They blow your body full of trillions of little tiny holes. Sometimes they damage the DNA code because they go right through the nucleus of the cell. But the body has a backup system where some of this DNA is in there twice. It's in there redundant. You have the same thing in your car. You probably have a brake and you have an emergency brake just in case, something goes wrong. So it's just wise planning to have a backup system. I don't think we know that there's any junk DNA anyplace. It's probably just a matter of they don't know the use of it yet. What they'll do is they'll take a cell and they'll clip out a piece of DNA and say, see, it lives okay. Well, that doesn't mean it was junk DNA. I think it'd probably be impossible to prove actually there's any junk DNA. It's just a matter of our lack of understanding of what it does, or it's a backup system.
I would agree 100% with you on that one, Dr. Hovind.
At least we believe that to be the case.
Well, like if we look at, for example, if we look at that junk DNA, right, that you were, because now we're seeing that, in that non-coding DNA, it contains sequences that act as regulatory elements, right? So that means they determine when and where genes are, say, turned on and off. And also those elements provide sites for obviously specialized proteins. I think those are called transcription factors. So they'll bind, and then from there, they'll either activate or repress the process by, say, which the information from genes is turned into proteins. So would you agree that those are pretty important functions?
I would say they have function, but technically speaking, they're not functional.
Okay, so what I just said to you, you don't believe that that's functional because in those non-protein coding regions, we see those regulatory functions. That's not function to you?
So the reason I want to consider it functional is that what's functional in an organism is the proteins and the various structures that are made as a result of synthesis of proteins. If you don't have something being synthesized, right? I mean, sure, you have regulatory elements, that's fine. But these regulatory elements don't do anything on their own. They're acting as a way to guide polymerases and transcriptases to monitor the activity of these genes, which that's perfectly fine. But it still doesn't transcribe a gene. It doesn't.
Now, do you think you're okay? Now, do you think you're putting a little bit of an evolutionary bias into that assessment? Because if these regions of non-coding DNA do provide instructions, say for the formation, which we just agreed for the formation of certain kinds of RNA molecules, like even CRISPR and I were talking about how non-coding DNA includes, and he admitted that this was actually functional. It includes transfer RNAs, right? And even ribosomal RNAs. And what does that do? That helps assemble protein building blocks, which is amino acids.
Sure. Yeah, I don't think anybody denies that RNAs are significant. I mean, the thing is that one gene can create several hundred different products, and that's mainly because of RNAs.
Okay, so obviously it's not idle then. So these non-protein coding regions are doing something. They're not idle. So in our model, that's consistent. And based on the fact that we know very little about the DNA code and the functions, because we're accidentally coming across various functions. So imagine we actually did these gene knockout tests. We're only going to obviously the trajectory is strong, say for genome-wide function. And I think based on your assessment, I think that's more of an evolutionary bias. Because to me, and I think to the majority of people, I mean, these are important functions, and any type of mutation on a gene that has a regulatory function will be deleterious. Go ahead.
Like I said earlier, I mean, I'm not denying the fact that it's not important, but if you're talking about function particularly, that doesn't matter, because you're talking specifically whether or not a portion of DNA is coding for some kind of product, which ultimately is a discussion that takes its roots in biochemistry. The really simple aspect of it is that, look, sure, there are things that are, that allow for polymerases to activate and to create a product. That's, sure, it acts as a regulatory sequence. It helps guide RNAs into place. But in the same sense, though, it's also not coding for anything. So to some extent, it's functional, but not strictly within a biochemical setting.
I think, well, for one, I would just disagree and say that, everything that I've been saying and we're agreeing on, I would say that is functional. I would say that a mutation on a gene like that would, create a problem for the organism. As it would be like a ripple effect, right? But I think it all comes down to models, right? So for evolutionists, the ultimate, and correct me if I'm wrong, the ultimate cause of genetic change is mutation, right? Like if you look at these nuclear DNA differences and these mitochondrial DNA differences, you would conclude those are based on mutations, correct?
Well, part of it's mutation, but that's not the most important aspect of it.
Okay, now for us though, and I'm sure you understand, like what would like for example, pre-existing heterozygosity, like I understand you don't agree with it, but what do we mean by that when we say that?
That there are genes that exist on, different chromosomes that we replicate via, that we can't replicate on our own, that we require the use of another human being to replicate.
Okay, yeah. So like millions of differences, say in the DNA sequences of chromosome pairs. We're saying that was built into organisms from the beginning by the creator. Okay, so when we look at the origin of species, we're saying that long periods of time is not required for the new species, because if we start with these heterozygous organisms, the visible distinctiveness and change in offspring, it's going to be fast. So if you look at things like recombination, gene conversion, that would provide many new varieties of, say, combinations of traits quickly, because we're saying these differences are already built in. So if we go back to functional versus non-functional, non-protein coding regions, we predict that, they're not going to be idle. They're going to have function, because if we're saying that these tens of millions of nuclear DNA differences were built in, if they're design variation, we'd expect them to have action. Okay, so obviously ENCODE revealed that 80% is transcripted, and now we're seeing more function. Like for example, pseudogenes, which we thought were false genes, actually show function, or something like protein moonlighting. We're seeing these proteins that have multiple function. That's consistent with us, because that's a prediction, a testable, falsifiable prediction based on pre-existing heterozygosity. But you're saying, obviously, these are not true functions, or it's spurious transcription. To me, that's a rescue device. How do you feel about that?
So it comes down to how you view something as functional. I mean, if you're considering the fact that one gene is transcribed in the course of, 8,000 runs as being functional, sure, that isn't really a valuable definition of functional, because it means that at best that, okay, there's a gene transcribed, but it's far from being transcribed regularly. There's some genes that are transcribed, 30, 40 times within an hour, let alone 30, 40 times within however long the duration of the experiment is.
So
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button, because we are just getting started.
Take a look at this chart. This is a representation of all the DNA differences in people from around the world. Let's say you take a look at blood sample or a cheek swab from somebody in Africa. then someone in Germany, then Spain, etc., going all the way around the world. Once all the indigenous groups of humans from around the world were tested, their genetic sequences were lined up and compared. This chart shows a few things. One, it shows that all humans came from 3 base haplogroups, named L, M, and M. These were the 3 daughter-in-law of Noah. Evolutionists interpret these nodes going back to African origins 200,000 years ago, which you are about to learn is impossible. But first, let's take a look at this chart, which shows that the different cultures from around the world have different DNA differences. So, using trio studies to determine mitochondrial rates in these individuals, you can see that young Earth creation is the only viable option, ruling out and easily falsifying evolutionism. Just look at this chart. We have discovered once every 6 generations there is a mistake that happens. On average, in the African branch, there are about 80 differences. In the non-Africans, there are about 40 differences. The most different individual you can find in all of these sequences are about 123. Averages are lower. This chart here shows you the averages. Well, if you do 1 DNA difference every 6 generations, and we're over 300 generations since Adam, you can easily explain these numbers. Now, what is 1 mutation every 6 generations in 200,000 years when they tell us that mitochondrial Eve lived? Well, that number is not found within any human being. This alone, if nothing else was discovered at all, completely destroys evolution. Even the largest critic of Dr. Jensen, who calls himself Rational Mind, even he admitted he had nothing to say against this. He accepted that the numbers were true because they are, as you can see from his very blog post. All he could argue about against this content was try to distract and direct it regarding the bar on the left, insisting that Jensen was showing such a high value of numbers when they can actually only go up to 12,000. Regardless, nothing alive goes anywhere near 12,000, so his complaining is nothing but a distraction, a rescue device to distract you from the actual evidence. But it gets better. This same mutation rate has been done in 4 other species besides human, and the scenario is the same and holds true. Far too many mutations predicted by evolutionists. So again, evolutionism is falsified. These results do not only disprove evolution, but they prove young Earth creation. And they also allow us to make testable predictions.
I'm taking the challenge to them now and saying, hey, let's go out and there's a fox in the woods. I bet you I can tell you how fast his mutation rate is.
They, however, cannot do this because they have an assumption method built into their model where they assume old-scale timelines to be true, so they add those numbers into their equations using the phylogenetic method. Remember, to them, mutations are the #1 main driving force of evolution. So, evolutionists should be able to predict anything, it would be mutations, right? And guess what? It was young Earth creationists who made the accurate predictions. There are too few genetic differences for long-scale evolution history to be true in every living thing that has been tested thus far. Evolution theory is now dead, and even the critics cannot refute it. The theory only holds on because laws protect it, and because it lives in the imagination of the indoctrinated who do not dare question it because they want it to be true. That is all.
And with that, we will go into the cross-examination, my favorite part. So we will let Standing for Truth start with the cross-examination. So we'll keep going with the normal order. And this will be 10 minutes. So this will be for each. And I am starting the clock. Standing for Truth, if you are ready, the floor is yours.
Okay, awesome there, Adam. Thanks for your rebuttal there. I guess my first question would be, because you talked about gene duplications and beneficial mutations, and I guess how many, if we were to look at numbers, how much gene duplications and say beneficial mutations are actually needed per year for millions of years to account for the the massive amount of living organisms that we actually see today. Because obviously just claiming gene duplications can add the necessary novel information to the genome and can be beneficial enough to outweigh the genetic damage and take your fish to fishermen. Is there a paper that would detail retrodictions on those numbers, or is it just more so a guess? Go ahead.
Well, you could look at the changing rates of DNA, and you can look at the divergence between, say, if you want an example of fish to humans, you could get your average fish genome compared to a human genome and say that's how different it is, and this is how this is the rate at which we think these mutations occur.
Well, I think keep going. Sorry, I didn't think you were done.
No, I'm done.
I think more so what I'm referring to would be like, even if we look at, say, Haldane's dilemma, like we know that a leading population geneticist, realize that even if there was an abundant and ongoing supply of, say, these beneficial mutations, natural selection must be very limited in its ability to amplify, right, such mutations to the point where they're actually fixed within a sizable population. So if you're going to, say, use gene duplication as your main mechanism for this large scale innovation, are there numbers, are there predictions, are there retrodictions, or is it just more of like a hypothetical or like an educated guess? Go ahead.
I think what you're asking me is, do the beneficial mutations account for us being here, despite? I'm not too sure, really.
Well, because if we look at genomic data, I'll try and make it a little more clear, right? Genomic data tells us that, well, we obviously know that the human genome is profoundly different than apes. So based on, let's say Haldane's dilemma, for example, there would need to be tens or even hundreds of millions of beneficial mutations that arose and then went to fixation during this time frame, right? So that scenario would require roughly, say, 1,000 independent beneficial fixations per generation. So according even to Haldane, that was almost an impossibility. So how is that resolved? Like, is there numbers? Is there any retrodictions? Because I guess that's what would make it scientific, right? Testable, falsifiable. Oh, can you hear me, Adam?
Yeah, I can hear you.
Like, do you find that Haldane's dilemma, for example, the problem of beneficial mutation fixation, I mean, is that resolved with actual scientific data, scientific papers, or in what you're saying in regards to, say, gene duplications, beneficial mutations, are there specific numbers? Are there papers out there that would break that down for us?
I imagine there could be. I invite you to go look for them. Okay.
If in regards to like building the genome, building that information that you're talking about earlier, I wasn't specifically referring to abiogenesis, but I did catch a few things on what you were saying in regards to DNA origins. From what I understand, evolution itself never actually predicted the RNA, DNA, protein system. And I think you said RNA evolved first, correct?
That's the common consensus, that RNA came before DNA, yeah.
So it sounded like you used a lot of, magical words like, probably, say, when explaining the RNA origins. And then obviously if we're talking about testable, falsifiable science, that doesn't seem like it'd be science. Like, are there testable predictions and retrodictions on DNA origins? Selection pressure, for example. Are there actual numbers, or is this RNA, DNA, protein system, the evolution of DNA origins, is this also more so like an educated guess?
The reason I spoke about it is because you brought it up in your rebuttal, so I felt the need to reply to it because you asked for it specifically. Aside from that, abiogenesis isn't my area, so my knowledge is to the best of it, and we're still not too certain on abiogenesis, so that's why I'm using deliberately vague language rather than saying this is fact.
And that's understandable too. I appreciated your responses there. Let's say with DNA redundancy, right? How did, because we die without DNA redundancy, we know it's really important. How did evolution, know we die without DNA redundancy? Since evolution, natural selection looks at the short term, how did that evolve? What was the foresight in something like that?
I'm not too certain on that. What, DNA redundancy?
Yeah, just all the redundancy that we actually see in the genome. I mean, would you agree? Would you agree with the statement that overall now, based on new evidence, that the non-coding regions of DNA function, say, much like an operating system in a computer, right? It's directing timing, expression, regulation, and use of the other information or the data files that actually code for the protein. So, like, how, with natural selection's limited foresight, how did this computer-like code evolve? And how is that scientific? Like, if you go back to testable and falsifiable predictions, I mean, do you have any answers to that at all?
DNA is pure chemistry. Everything about DNA works within the bounds of chemical laws and everything we know about chemistry. So there's nothing about DNA that we wouldn't expect. Going back, it's all about the origins of DNA, because everything else is explained purely by the concept of chemical laws. So unless you're asking for the origins of it, I don't know what the problem is.
I would just say the building of a genome, say, from the single-celled organism. And I guess if you're talking about DNA chemistry, if we look at something like alternate splicing, which I think clearly shows design way beyond what evolution could do, how did each exon learn how to manufacture different proteins? Also, why are there bits of sequences teaching and regulating the exon? So it just seems like it's so much more than just chemistry. And I guess I'm just using the example of alternate splicing for now. Go ahead.
DNA is like an old football. It's a bit of a mess, really. There's scratches on it, scrapes. Bit of the fabric has worn off and disappeared. There's bits of grass stuck in it. DNA is a mess, and the only reason that can really be explained is by looking through the DNA of a whole host of different organisms and seeing how they compare, which bits are the same, which bits have changed, and comparing that to morphology, to the animals we have, how we see things today. That I don't understand what is you're asking, really, apart from that. How it's formed, how all these things came together. You're asking a very vague question of, I don't understand how this works. Tell me how.
I think I'm just saying that based on and in light of all the evidence about DNA function, it seems like we're dealing at this point with a highly compressed DNA code beyond the best computer code. We know we write books. We don't write books that can be read both forwards and backwards. So if, say, natural selection mutations had to build this genome, and I'm not, specifically talking about abiogenesis, of course, but if evolution is true, given the, millions or billions of years of evolution, I don't see how evolution could build such a highly compressed DNA code is what I'm saying. Like, do you find it more plausible to say there was no designer? I guess would be the best question in regards to that.
Put it this way. As I mentioned, there is nothing in DNA that doesn't follow the laws of chemistry. Therefore, we've got no reason to suppose it was something supernatural that doesn't follow the laws of chemistry that could have brought it about. We have to assume that because it all follows laws of chemistry, that it all follows laws of chemistry. And that's how it formed. We can't just say, oh, this is too complicated, therefore God did it. We can't do that. It's just not feasible.
But if DNA is a mess, as you say, how then does it produce, just say us, for example, so well? Like, for example, Hox genes?
Because when it doesn't produce as well, those organisms die.
Sorry, I gave you a message in the internal Google chats, and then I also tried to hold up my finger. I hate to cut you off, Standing for Truth, but
that's okay. That's okay. Sorry, but we could probably go on with that forever. That was fun.
No
That was
problem.
good fun.
So thanks for your patience. And then we will give Adam, or Steam Driven, his 10 minutes to cross-examine Standing for Truth and resetting the clock. The floor is yours.
Okay. Oh, good starting point. Can you give me the different process in macro to micro evolution? What process is different?
So I would say if we're looking at micro and macro evolution, I don't personally like to use those words, because even in regards to our model of, say, created heterozygosity, right? God created, let's just use Adam and Eve, for example, with pre-existing DNA differences. So through processes like recombination, gene conversion, I mean, that would provide many new varieties quickly, since those differences are already built in. So I mean, certainly in regards to the biblical based model, I mean, we're going to predict change. Okay, and evolution means change over time, change in allele frequency in populations over time or generations. I think it just comes down to whether or not there's a limit to that change. So it's hard to say exactly what the difference between micro and macro is, because like I said in the opening, like that type of micro evolutionary variation where you get, a change in the frequency of the expression of different traits, I'm not disputing that, right? Because that does explain the survival of the fittest, but just not the arrival of the fittest. So I think it comes down to whether or not there's limits and how far you can take that change. Are dogs and bananas related or through common ancestry? I mean, I think there'd be a limit there.
Okay. So would you consider speciation to be part of micro or macro evolution?
I would say according to the biblical based model, speciation, say from shifts from heterozygosity to homozygosity, because that's how we would explain the rapid speciation since creation and since the flood. So speciation is important, and there's been documented cases recently. Actually, Dr. Nathaniel Jensen wrote a paper on it, where in real time, finches, it was observed that there were shifts from heterozygosity to homozygosity due to inbreeding, leading to a new species of finches. So that's actually what we would predict based on pre-existing heterozygosity, created heterozygosity, I should say. I'm not against that. And I wouldn't say that that's macroevolution, because I mean, there's still finches, there's still birds, but the change we've seen in that allele frequency in those populations of finches is expected and predicted under our model. So I think I wouldn't say that that's macro though.
Okay, next question. If we go back to my bottles on the wall example, would you consider that an increase in information?
Can you, I'm looking at my notes here. I have a lot of notes on everything you said.
Okay, yeah, I basically said you have 10 green bottles to start with. Then there's a mutation where one of those bottles becomes blue. Then you have another mutation where the entire sequence is copied. So you've got 18 green and 2 blue. And then there's another mutation where there's 1 red, 2 blue, and 17 greens. Is that an increase in information?
Well, it sounds like it's because what I was saying, shifts from heterozygosity to homozygosity was leading to speciation, say in a real-time example of these finches. So in your example with the bottles, I can't see what's going on a genomic level, on a DNA level, to see if it is a loss of information. Because if a lot of the examples I see of, say, speciation beneficial mutations, if it is decay of prior information, I don't believe that's going to take your fish to fishermen. So it's hard to say. I get your analogy with the bottles, but if you could reiterate the question a little bit differently, I mean, how can I conclude if it is an increase in information?
The analogy takes single point mutations, so the green bottle will change to blue, and polyploidy, which is the entire set duplicating, which we do witness. And it was just an analogy to say replace chromosomes with the bottles, and those are things we have seen. So I'm just asking whether that's an increase in information.
I would say I would say that it's, let's say gene duplications, for example. I think, and we might be able to agree to this, Adam, I think gene duplications are almost universally deleterious. So say a few rare beneficial duplications, I don't see how those are going to be able to offset the many accumulating deleterious duplications, let alone all the other accumulating mutations. And with your bottle colors, those color changes in regards to our model, those are pre-programmed in our DNA. So that information is already present. There's no new novel and meaningful information added. And probably like all examples of beneficial mutations, it probably is decay of prior information. Does that help answer your question?
I mean, I would disagree on it, but I'd like to ask another question.
Of course.
Got about 4 minutes left, and it's nice to have these little discussions, and they could lead on from there. But my next one was, how do you explain the gradual movement of marsupials from North America through South America, over Antarctica, and into Australia?
Okay, so actually, can you repeat that? So the gradual geographical distribution of marsupials?
We find fossil marsupials ranging from North America through South America, over Antarctica, and into Australia. And the way we date them shows that it happened over time. So it lines up perfectly, moving from North America through to Australia. Can you explain that?
Of course. Like I would say, obviously, if we're looking at, so you mentioned the fossil distribution of these marsupials. I mean, short answer would be, post-flood ice age, post-flood environmental conditions, because, we look to the flood to explain the fossil record. So if we actually look at the upper layers, because you're talking about the upper layers where we're observing these marsupial distributions, correct? The fossils?
They do come from different layers.
Okay, so I would say that the layers that we see them in, based on our model of post-flood ice age, we see in those layers post-flood diversification and dispersion, and I think it's readily explainable through. I'm not sure if you've read much, creation literature, technical papers, but we say that it's explainable through land bridges, floating mats during the ice ages, right? And we can see that animals can be distributed around in very natural means, even in real time, say during cataclysmic events. So given a flood model and flood geology, I don't see a problem in that geographical distribution. Go ahead.
So you say that marsupials went from the Middle East, they traveled to North America, then down through South America, then over Antarctica, and then to Australia. Because we know that no records of marsupials being in North America or Antarctica have been found by humans in recent times at all. So say, give it 1,000 years, max. Is that possible?
So 1,000 years since the actual post-flood ice age.
Since the flood.
And you're trying to think, and you're saying that the distribution of these marsupials is conflicting to. Yeah. And based on the remodeling of, say, the Earth post-flood, well, for one, I know you mentioned, dating methods. I mean, I'm sure that could go on a rabbit trail, so we won't go on that. But I would say that there's a lot of assumptions and guesses in there. So, I mean, for me, I disagree that would be reliable. But yeah, ice age producing land bridges to cross and the distribution that you see. But the thing is, these animals, thousands of years ago, based on our model of pre-existing heterozygosity, I mean, the variation, the biodiversity, I think would be even in excess as compared to what we see now. So yeah, are you saying that there's a lot of variety in these marsupials in these geographical related areas?
Yeah, they're not the same as today's marsupials.
Yeah, and I wouldn't expect them either, because shifts from hetero to homozygosity for us in explaining speciation, I mean, post-flood land bridges, post-flood environmental conditions, because you can't look at the Earth now and assume that that's exactly the way it was before. So I think that is a plausible explanation for the geographical distribution of not only marsupials, but all other life and diversity that we see as well.
Okay, one more question to finish us off.
Yeah, of course.
What's the point of a skink with stumps? I mentioned earlier a skink that has merely a couple of stumps near the front of its body that have no purpose whatsoever. What's the point of it?
I'm sorry. So it's a couple of stumps in front of its body that has no purpose?
Stumps. They've lost the claws. There's just a stump on either side.
Well, I know you mentioned, because I would say a loss of information. The evolutionists will use a lot of examples of losses of information as if, hey, lose everything and we'll gain it all. But in regards to that exact reason as to, if it's a specific mutation that made them lose the information, and it's a deformity, is what you're saying, correct?
It's a mutation. It's not a deformity. No, it's an actual species of skink. I forget its exact name, but it's a species that has stumps.
Maybe we don't know the purpose yet. For example, how many vestigial organs were listed even 100 years ago? I think there was 140. Now they're all known to have a function. Now we're seeing this in the DNA language as well. So do we know, and do we have conclusive evidence that it has no purpose?
Time.
They're pretty useless. We'll finish there.
Excellent. So thank you.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started. Hey everybody, this is Standing for Truth, and this video consists of the portions of my debate with Emotionally Stunted Emoticon, where we discuss LMN haplogroups and mitochondrial DNA. For the full debate, please refer to the link in the description box. I highly recommend this. We touch on many different topics and it's very engaging. In the meantime, please enjoy this video.
So if you actually look at this visually here, so if you can see my arrow, what these are, and they're well known as the three major haplogroups. And I want to point out the fact that these lines here, so if you can see my arrow here, they all come back to a common origin and basically three different common groupings. You can see here the three groupings, okay? That's the LMN haplogroups. Of course, there's subgroups, but this is not a point of dispute, as even the evolutionists here themselves, they recognize this basic fact. So in technical terms, these are the three major haplogroups, L, M, and N. Now, this is standard evolutionary science and belief. So you can even watch my debate with Dr. Stefan Frello, who's had a very extensive written debate with Dr. Jensen regarding these haplogroups. Now, where the prediction comes into play is because I'm defending a biblical creation model here. So therefore, when we look at this mitochondrial map here, what is the maternal ancestry of the human population? So if you look at your Bible and you take you open it to Genesis, what do we start with? Well, we start with Adam and Eve, who then have many children. We then move quickly here to the time of the flood, of course, and how many female lineages survive the flood? Well, there's Noah, there's his wife. Now, Noah's wife passes on mitochondrial DNA to her sons. But what does it do? It stops there. So Noah's three sons obviously do not pass on their mitochondrial DNA, but their three wives do. So we actually trace back to three women. Now, what's actually amazing about this is the fact that it makes predictions directly from Genesis. And the relative pattern we see, as we know that DNA differences are a marker of time and that they're a marker of thousands of years, not hundreds of thousands of years. How many generations were pre-flood and how many were post-flood? Those are important questions. So as I've said, reading the Bible, reading Genesis, we know that on the paternal side, there are about 1,600 years or 10 generations or so. So consisting of obviously very long lifespans, which we can actually look at and confirm based on just genetic entropy and legends, thousands of legends. So we actually see the lifespans dropping off quite rapidly post-flood. And so we probably got, a couple hundred generations post-flood. So we see very little time for mutation pre-flood and longer branches post-flood. that indicates more generations and more differences / mutations. So the mutations would also explain the long African branches here. We're going to have Emotion comment on this, but we have a few potential explanations for the longer branches here that you can see. Africans could undergo a faster rate of change, or even an explanation involving UN data in the 70s. And what the data told us was that women on average in Africans married early, whereas the rest of the globe, not so much. So if this was actually true historically, and that's what's important, is that Africans would have gone through twice as many, maybe 3 times as many generations, and therefore mutations than non-Africans. So there's been mutation rate predictions on the Khoisan peoples. Evolutionists can make predictions as well on this mitochondrial map, but it's the creationists that are making the predictions right from genetics. Fossils, bones found in the dirt, they're not inherited. Genes are, traits are, and that's what we're looking at here. Go ahead there, Emotion.
The haplogroups, you've spoken of haplogroups a long time. Usually the common objection is that M and N were derived from L. Most people object to that. Even if I grant you that they didn't descend from L, that they came from all 3 came from a common stock, we still have the problem of the archaic humans, the extinct humans that do not fall anywhere near the DNA haplogroups we have there. I've heard creationists talk about the fact that DNA tends to degrade, not genetic entropy, but the DNA itself, the molecule tends to degrade over time when an animal dies. That's okay. But we would have to explain why, when we measure the DNA of the mitochondrial DNA of different specimens of Neanderthal, why they tend to fall together. If DNA degrades and they can cause inconsistent readings, why does inconsistent or unreliable data yield consistent results? That's what we need to know. And we also need to know, when did these Neanderthals went extinct, because their DNA, mitochondrial DNA falls so far off. How much time are you giving them to accumulate that difference? All right. Because of course the assertion or the argument that the DNA is too degraded doesn't hold up when you actually compare all of them and realize that, well, if all of them are degraded, then, again, why are you getting these consistent results? So we need to know when they died and so on, the specimens when they died, and how do we get all that difference between the time? Because they don't have 4,400 years as we do. We're current animals or extant animals.
If it's based on adaptive degeneration, like I said, it's not going to take your microbes to man. It's just not going to do it. And we want to see empirical evidence, not ideas, wishful thinking, imagination. You can hope, dream, and imagine all day. Let me see here what he wrote. Real quick, was it the Neanderthals that was your prime objection to Dr. Jensen's haplogroup map here there, Emotion?
Yeah, the Neanderthals and the Denisovans.
Okay, so it's not, okay. So if you're looking at, say, these ancient, like, you can even look at Replacing Darwin. You can look at the book on this section, where he actually makes very specific predictions on fossil DNA sequences, as you're talking about. Even based on genetic entropy, there's a paper out that talks about Neanderthals and how they were susceptible to this genetic entropy based on isolation, inbreeding. They had a very high genetic load. So the prediction made by Dr. Jensen that, these Neanderthals are just hypermutating lineages actually does hold water. It actually makes a lot of sense. So the fact that these 3 major haplogroups are absolutely consistent with the biblical based model, the 3 wives of Noah's sons, and how all these lines go right back to just that, LMN. I mean, this didn't have to be true under an evolutionary model, but predictions have been made on the most divergent of African people groups. They're making predictions on mutation rates. I want to see the evolutionists doing the exact same thing. In the young Earth creation model, it easily accounts for all the mitochondrial DNA differences among modern peoples. And Dr. Jensen's proposed explanation for Neanderthal DNA, whether it's just degradation, but we've seen in papers that they had a very high genetic load, especially immediately post-Babel. You're isolated, the environments, the conditions, you can mutate fast, and therefore you're going to have that excessive amount of degradation, of mutations, or even just lineage-specific mutation accelerations, as I'm talking about here. The thing is, you know, what Emotion Needs understands, those flow from Dr. Jensen's explanation for modern observable mitochondrial DNA differences. And based on that model, as I've said, predictions on the rates of change in some of these sub-Saharan peoples, they've been made. And therefore, the evolutionists need to step up and do the same type of thing. So, you know, that explanation for modern mitochondrial DNA differences, it meets the standard of testable predictive power, but the evolutionary model, it doesn't. So you can nitpick all day, but you also said, you know, the Denisovan DNA, fast mutation rates in the Neanderthal and Denisovan lineage, or the DNA degradation of these lineages as well. They, at the end of the day, have been indirectly confirmed. So I want to see Emotion here in the next response. I want to see him, if he's going to continue to reject those claims that I just made on Neanderthals and the DNA of Denisovans and these fossil DNA sequences. I want to see him propose a better testable predictive explanation for modern, but not only modern people, ancient human DNA samples, and he needs to provide an independent test of the reliability of ancient DNA as well. Because in the experiences of scientists, geneticists, looking at DNA even from living species in a lab, when stored, this DNA, you can see that even beyond a year, those DNA samples, they do give unreliable and unpredictable results. So how much more caution is then warranted when dealing with DNA that is sat in an open and fluctuating environment for hundreds, if not thousands of years, such as with these Neanderthals and Denisovans and these ancient human populations? So there's two explanations. They make predictions. They also flow from this tree that I gave earlier. I want to see a better predictable model from Emotion.
Kind of like a mosquito. You got to just once in a while, you got to swat them.
Recombination happens all the time.
The same genes.
That recombination happened to make you and me.
Wow.
Recombination doesn't move entire gene sets, each one which are
that's my point.
to each other and related to critical functions such as cell tissue specializations and coding for helicase. Can you tell us why it's what I find remarkable, Dragnuck, is that I just provided you with a scientific discovery that it's been discovered that these genes, which code for helicase and which determine code for RNAs, which specify developmental processes such as cell line, cell tissue types, code for proteins, make microRNA sequences, and code for the helicase machinery that duplicates the DNA molecule, and you call that incredulity. So you call scientific discovery incredulous for your evolution theory. But my question remains, why do you believe it's plausible that random mutations are going to build these gene sets that span the chromosome fusion site after the fusion has taken place. Why should we believe that that's plausible?
Back in SpongeBob La La Land.
Okay, so I'm going to answer this real quick. Superbad, you and I are going to have to talk more one-on-one later when you don't have someone interrupting you every 2 seconds. But so Nafi, there's something you need to understand. As someone who's never stepped foot in the lab, and as me, as someone who actually regularly goes to a lab, science isn't based on what I believe. It's based on what's demonstrable. That's something that you severely need to understand here going into the future. So
You didn't answer my question.
on that note,
There's nothing to cry about, okay?
CRISPR, man, I know I opened this topic up for you.
Okay.
So you can't answer my question.
Go ask your mama to explain it to you, okay? It's not hard.
Me, as someone who actually regularly goes to a lab.
So you can't answer my question. You can't answer my question. You can't answer my question.
If you're implying the Big Bang theory is true, Dave, how do you explain, say, the horizon problem, which seems to be a big problem for Big Bang theorists? Like, how would you explain it, being a physics major?
What about the horizon problem?
Well, like in a nutshell, in the model, correct me if I'm wrong, the universe begins at an infinitely small state called a singularity, correct? And then it rapidly expands from there?
Yeah, and it's still expanding today.
Okay. I just want to explain the problem to you and see how you explain it, because according to this model, when the universe was still very small, it would have developed different temperatures in different locations. So let's just suppose, I'll try and simplify this, point A is hot, point B is cold. Today, the universe has expanded, and points A and B are now widely separated, right, Dave? Are we on the same page in this?
Yeah.
Okay, but we know the universe has an extremely uniform temperature at great distances beyond the farthest known galaxies. I mean, are we in agreement here?
Yeah, I can't argue.
Okay, so in other words, points A and points B have almost exactly the same temperature today. We know this from the electromagnetic radiation coming from all directions in the form of microwaves, right? The microwave background.
Here's the thing too, and this is if I go too fast, stop me. But we also observe that the expansion of the universe is accelerating, which implies an increase in energy in the universe that we can't explain. Also, the speed at which things are moving are faster than what they are, which shows an unexplained mass out there. We call these things dark energy and dark matter. We have no explanation for those either. There's a lot of things that we don't know.
I consider that dark
science. Still doesn't say that there's a divine creator existing outside of space and time that created it all.
But I'm just saying, in the Big Bang model, if it's true, right? How are points A and B the same temperature? Because the only way they can be the same temperature, Dave, is that they need to exchange energy, right? But at the end of the day, there would be a huge light travel time problem, because they must have exchanged light multiple times. You would need
things are getting further away from each other. They could have exchanged lights multiple times when they're closer together. We don't know.
But but we know the universe
you're inferring that the God of the gaps is a acceptable reason to say that there is definitely a divine creator. Because we don't know something, God must have done it. That's just not the way it works.
Well, I'm just saying there seems to be pretty big problems with the Big Bang.
Maybe someday we'll find out. We don't know everything yet.
So if we don't know everything, and
if the God of the Bible is right, that should all be explained in the Bible. It's not.
It is all explained.
Ask Standing for Truth how young Earth creation deals with distant starlight in a young universe.
Jackson 4 looks like super not bad. Gives me another tough question to answer. You can certainly go with the supernatural explanation. I mean, obviously, God created a full-grown Adam, full-grown garden, full-grown mature Earth. If scientists were to come and do their blood tests on Adam, who say was created just an hour before, you know what I mean, based on height or weight, they might conclude that he's old. Based on blood tests, cholesterol levels, they might conclude that he's young. So at the end of the day, looking at starlight, if God stretched out the heavens, as the Bible says, you can certainly go that route. I prefer to go the more scientific route. Dr. Humphreys, gravitational time dilation. You'd have to go through a lot of reading material to understand. It's kind of hard to go in a 1 minute answer, but if we assume the Earth is, say, at the center of mass in space, something in the center of mass will create a huge dent in space. Okay, now we would also have to assume that God used what's called a white hole to bring about the universe. Now, given the two scenarios, if you're following me, the Earth is in a huge gravitational well, and deep inside a gravitational well where time slows down. Okay, so here's the explanation. And the deeper you get, the slower time gets to the point where time itself stops. Now, while the Earth is inside that well, God also created stars and galaxies inside that well. This is where it gets interesting. So the Earth, and I'm trying to put this into a nutshell. So the Earth and the stars are inside the well at the same time. And that well is a white hole, like I said earlier. But while God was putting stars and galaxies inside that well, it causes the original dent in space-time to increase further, sending the Earth down much further into that well, causing time to completely stop. I know it's kind of technical, but it does explain the distant light problem. Now, while Earth clocks were stopped and everything from stars and galaxies was inside that white hole, just like the Bible said, God stretched out the heavens, which means, I think it's pretty obvious, he expanded the event horizon of the universe starting from the edge of that white hole. So when he stretched it out, stars and galaxies were the first to come out of that well. And when you escape that gravitational well, time can now start ticking. So which clock started ticking first? Right? Stars and galaxies or deep space? I'm almost done here. I just want the audience to understand that we do have a strong model, because starlight started traveling from the event horizon to the center of mass, which is the white hole. Now, as God continued to stretch out the universe, the Earth finally was pulled out of that white hole, and for the first time, Earth clock started to tick. When Earth clock started ticking, since galaxies and stars came out of that well first and had billions of years of cosmic activity, while the Earth was still in that well, light from those galaxies already traveled to the center of mass. And when the Earth came out of it, light, distant starlight was already there. So I explained that in a nutshell. I'm very interested in this distant starlight problem. That's the best I can explain in the limited time I have, but I would definitely suggest people look. You can go with the supernatural explanation, or you can go for this really technical explanation. Dr. Humphreys, I recommend looking into it. It completely solves the problem.
So,
okay, good night. So, I mean, I think ultimately what the crux here lies down to is molecular phylogenetics, which you're just going to claim it's dirt in the ground, but unfortunately it does a lot more than that.
Well, I would say that, wouldn't you say phylogenetic systematics relies heavily upon non-functional nuclear and mitochondrial DNA differences? Like, isn't that a primary assumption? Because that all goes back to now, the junk DNA argument. That also goes back to these differences we're talking about.
We can include that if you want to, but that doesn't change the result.
Yeah, but I'm trying to say, if you're looking at these genetic markers and assuming that they're evolutionary leftovers based on past common ancestors, and we're showing that these are actually functional differences based on pre-existing heterozygosity, that means these phylogenetic charts are based on a primary assumption that molecules to man evolution is true, but now we know it's not true, so now these phylogenetic charts are just lines on paper. Go ahead.
No, so none of that needs to be assumed. What needs to be assumed is that certain genes that exist in the past have some distinct function that arose from previous genes that we can find within organisms, and that we can map and somehow determine a distance and somehow an age for these organisms and for these genes that we're observing.
As he said, those are just lines on paper. That's what it comes down to.
Because the whole point is, if they're functional, they now become a common design argument instead of a common ancestry argument. So just like Warning said, now they're just lines on paper, and lines on paper aren't evidence for anything, really. And I understand that if they are just plagiarized mistakes, because I understand the evidence for evolution very well. And yes, plagiarized mistakes would point to universal common ancestry, but if they're functional DNA differences encoded from the start, then no, that's evidence for design, and that's a prediction made, by our model. Go ahead.
Well, I mean, it depends on what. So again, for something to be functional, it has to have something that can cause it to function.
Well,
Which,
do you
if you're
want me
dealing with
to?
a bone in the ground, that's not going to work.
I've already told you that, expressive, regulatory, embryological, placental roles, these are functional roles. And clearly ENCODE has revealed that 80% is transcription. I understand that you say that that's spurious transcription, but it proves that they're not idle. And it proves that we know very little about the genome. For example, protein moonlighting is something that was newly discovered, not too long ago. And that reveals that proteins have multiple functions. And the more we learn and study the genome, the more we realize just how complex and functional it really is.
Of course. I mean, that's not surprising.
Well, that's evidence for
it's multidimensional functionality.
No nucleotide in the genome is idle anymore. That's a fact. So spurious transcription and just labeling all these important functions that I've stated as not really functional at all. I mean, I see that personally as a rescue device because idle was the basis of for junk DNA in 2001, but now we know they're not idle. So now the theory has to be adapted to fit the data. There's always a lot of adapt. Let me ask you, how many vestigial organs were listed 100 years ago? Wasn't it like 140 or something?
I don't know. Probably. I'll take
it was about it was like 142, and now there's about 5 or 6 arguable ones that I would say aren't vestigial, but that's a huge difference. So that's just based on ignorance, because obviously they didn't realize what things like our tonsils and our thyroid and obviously the appendix and coccyx and all these different things were for. But now they realize that these things actually have important functional roles, and now they're not listed as vestigial anymore. So how do you feel about that?
Well, it's based on existing data, just the way Hes Mendel tried to prove with his own experiment.
Exactly. So
people make wrong conclusions. That's perfectly fine. That's how scientists learn.
So what makes you think that these vestigial genes or pseudogenes or junk DNA is not exactly the same thing as the ignorance of the vestigial organ era? It's the same thing. I mean, I don't see why you don't see that.
No, because I would see that, if a gene is indeed functional, if it's non-vestigial, we should see it being transcribed in an organism at a relatively at a regular
80% transcribed.
Sure. I mean, how much of that is spurious transcription now? Once again,
I would say very limited of it, based on all the important functions that I've already listed, and I can certainly go back to those.
Would you consider one transcription event out of like 80,000 to be rare?
Well, like I said, no nucleotide in. Well, I don't believe that that's even the case, because I'm saying no nucleotide in the genome is idle. I'm saying it's all functional minus a few pseudogenes based on genetic entropy. I mean, that's our prediction, and it seems like we're the ones that are making the predictions. It seems like you guys are just coming up with all the rescue devices based on all the current literature. Go ahead.
Even if some percent of it is, even if it is all dynamic, there's only certain regions that are functional. We've mapped the human genome, and we can tell which parts are functional and which parts aren't. I mean, you could alter a gene and make it functional, but that's not exactly the same thing as dealing with something that already has, that's already existing.
How do you explain the sudden appearance of biological features in the fossil record, followed by rapid diversification? And then use an example, as was with the case of insects and their wings. And he also says he has a source for that, and he also mentions the Cambrian explosion. Go ahead.
The fact that they date millions of years apart. Can you explain why the chemistry is wrong from the dating? Since they're millions of years apart, there's going to be some gaps. It's like taking a picture every couple million years. So we don't have a picture of what's in between the gaps. So you're going to see some certain features develop suddenly, but it's not that sudden because they always have precursors, unless you're talking about the single-celled microorganisms that we found at the bottom.
Okay, unless Dr. Hovind has something to respond to with that, I can move on to the next question.
No, very quickly, I think the sudden appearance, first of all, you're still assuming that the fossil record exists and means something. I would disagree with that. I think that all the fossils we find in the ground indicate rapid burial, like Noah's flood would do, and represent a sorting based upon a variety of things: intelligence, mobility, body density. Birds are found on top, clams are found at the bottom. That's got nothing to do with evolution. Clams are heavier than birds. Bird feathers are light, their bones are hollow. And birds can fly around until they run out of gas, and of course they're going to be buried on top. Got nothing to do with evolution. You guys want to interpret all the fossils to fit your theory. I can interpret all the fossils to fit the creation and the flood model just fine. When they find the earliest, even if the geologic column was true, the earliest fossils found in amber, for example, insects are identical to today. Where have the changes been? The mosquitoes already had wings. The bees already had wings. They're found in amber from supposedly hundreds of millions of years ago. Where's the evidence of a wing slowly developing on a mosquito? Where's the fossil of that? Because the amber shows them fully developed, capable of flying just like today. I think it's ridiculous to believe anything other than rapid creation, fully symbiotic relationships by the millions, and a flood that destroyed it all, burying them, forming the fossils. No fossils are forming today. How many animals died today? Millions. How many fossilized? None. It's a special process. It has to be buried rapidly, like Noah's flood would do. So Peter, 2 Peter in the Bible says the scoffers are ignorant of that creation and that flood, willingly ignorant. And that's the case what we got here.
Awesome. Thank you. I appreciate that.
So Brian,
okay, let me respond real quick. So those changes you're talking about, they're going to have to be obviously significant enough to create true novelties and innovations. So obviously just shuffling of this existing information, it's not going to produce a new genome or a new code from that English book. I mean, it's, for example, E. coli, Lenski's E. coli experiment. Bacteria have very short generation times. They've been doing this experiment for years. How come they haven't gotten anything other than a bacteria? If we're going to see large-scale evolution, new information, an English code to a German code, why don't we see that? It's not.
That's not an expectation for things that leave their domains.
An English code to a German code.
May I?
Yeah, sure. I'll fuck off. It's fine.
Yeah, Sam, I don't want to step on your toes, man.
Well, no. I mean, like, listen. If we want it to just be a group discussion, he wanted a one-on-one. Like,
yeah,
I'm kind of I'm just getting kind of confused by it. I'm not frustrated.
Yeah.
No, I'm frustrated.
Yeah, I'm just going to have to
if I see populations of dogs producing other dogs, and then you say a population of dogs today came from a population of non-dogs long ago and far away, but yet you can't show me or provide me a mechanism of how that's possible, I'd be frustrated too, guys. Ponds come to people evolution. You can believe it all you want, but it's just not science. It's not observational, operational science.
Must
Are we being
Okay, so I am curious with emotionally stunted emoticon here. Let's say, if you expect to see evidence of genetic entropy, say within a biological setting, non-domestication, we would need, an experimental organism that has both a short generation time and a relatively high mutation rate, because obviously, long-lived organisms such as mammals, a genetic entropy experiment, minimally, it's probably going to have to last hundreds of years, right? Especially if these near neutral mutations are invisible and they have such tiny effects. It's tough to see them in real-time experiments. But let's take something that has both a short generation time and a relatively high mutation rate. So, for example, RNA viruses, which I believe are uniquely suited for that purpose. If we could see RNA viruses degenerating quickly based on the fact that they have, both a short generation time and a relatively high mutation rate, would that be convincing evidence to you or no?
RNA virus. So you wanted to see in a natural setting. Okay, so what I have to do is to find a population that is, that has that high mutation rate, not inbred, not domesticated, and test them to see if they do have an influx or of deleterious mutation, if they have a heavy load of deleterious.
But I'm just saying, like, if we were to look at something that has short generation time and relatively high mutation rate, that could be, genetic entropy on a small scale versus, say, long-lived mammals on a long scale, right? We can see if it occurs in this type of, like, for example, an RNA virus, they have short generation times and a relatively high mutation rate. So if genetic entropy is true, shouldn't we logically see something like that? Because, for example, bacteria, they have short generation times, but they also have a lower overall mutation rate. But RNA viruses, they have short generation times and a high mutation rate. So the fact that we've seen, let's say, the H1N1 human version, for example, we've seen the H1N1 human version go from a red hot pandemic to a whimper to an extinction event in 90 years. Now, from what I understand, the evolutionists, and I'll get your input here, they don't seem to know why exactly the H1N1 virus went to extinction, but I believe they chalk it up to adaptive evolution. But I don't see how adaptive evolution could cause extinction, because it looks like the virus, okay, and there's a really, really technical paper on it. So I'm just going to kind of go with, in a nutshell, from what I know, it looked like the virus started off more human in its codon usage and ended up randomized. It became worse, okay, at interacting with human DNA over time. And if it is using the wrong codons, that means it will be less efficient at replicating in human hosts. So it looks like there is a decline in functionality, and it matches exactly with genetic entropy. It also explains why the mortality rates went down, and it also helps to explain why the strain went extinct. So is that not genetic entropy in real time? Would you accept that as evidence or no? And if no, why not? Go ahead.
Again, I'll have to investigate the circumstances of what caused it to go extinct.
Okay, good.
Again, I'm not too sure if it's maybe the host environment, the human, if maybe humans found a way to combat the virus and then it went extinct that way.
Well, it looks.
I'm not too sure. I'm not sure the exact consequences.
Well, it looks like the codon bias declined consistently over time. That wouldn't be consistent with adaptive evolution as far as I'm concerned, and it shows clearly that they got worse, so not better, at interacting with human DNA. Now that correlates to slower replication, and that also means less lethal infection. So the viruses became less lethal because why? Well, they got worse, not better, as I stated, which is exactly what we would predict, at doing their one and only job, which is replicating themselves. So short generation times, high mutation rate. It's been studied, very technical paper, peer reviewed, I believe, in the NIH journals. I'll send you the paper, okay, because it sounds like you are genuinely interested. I'd like to see your feedback. But that seems to be genetic entropy in real time. So if all turns out well after you read the paper, would that be sufficient for you to validate the genetic entropy thesis? Go ahead.
Sure. Again, if I do read the paper and I find that it seems that the virus itself was getting weaker instead of the human immune system getting stronger against it, then sure, then it should count as genetic entropy.
If all turns out well after you read the paper, would that be sufficient for you to validate the genetic entropy thesis? Go ahead.
Sure, then it should count as genetic entropy.
Okay, so I am curious with emotionally stunted emoticon here. Let's say if you expect to see evidence of genetic entropy, say within a biological setting, non-domestication, we would need an experimental organism that has both a short generation time and a relatively high mutation rate, because obviously long-lived organisms such as mammals, a genetic entropy experiment, minimally it's probably going to have to last hundreds of years, right? Especially if these near neutral mutations are invisible and they have such tiny effects. It's tough to see them in real-time experiments. But let's take something that has both a short generation time and a relatively high mutation rate. So for example, RNA viruses, which I believe are uniquely suited for that purpose. If we could see RNA viruses degenerating quickly based on the fact that they have, both a short generation time and a relatively high mutation rate, would that be convincing evidence to you or no?
RNA virus. So you wanted to see in a natural setting. Okay, so what I have to do is to find a population that is, that has that high mutation rate, not inbred, not domesticated, and test them to see if they do have an influx or of deleterious mutation, if they have a heavy load of deleterious.
But I'm just saying, like, if we were to look at something that has short generation time and relatively high mutation rate, that could be, genetic entropy on a small scale versus, say, long-lived mammals on a long scale, right? We can see if it occurs in this type of, like, for example, an RNA virus, they have short generation times and a relatively high mutation rate. So if genetic entropy is true, shouldn't we logically see something like that? Because, for example, bacteria, they have short generation times, but they also have a lower overall mutation rate. But RNA viruses, they have short generation times and a high mutation rate. So the fact that we've seen, let's say, the H1N1 human version, for example, we've seen the H1N1 human version go from a red hot pandemic to a whimper to an extinction event in 90 years. Now, from what I understand, the evolutionists, and I'll get your input here, they don't seem to know why exactly the H1N1 virus went to extinction, but I believe they chalk it up to adaptive evolution. But I don't see how adaptive evolution could cause extinction, because it looks like the virus, okay, and there's a really, really technical paper on it. So I'm just going to kind of go with, in a nutshell, from what I know, it looked like the virus started off more human in its codon usage and ended up randomized. It became worse, okay, at interacting with human DNA over time. And if it is using the wrong codons, that means it will be less efficient at replicating in human hosts. So it looks like there is a decline in functionality, and it matches exactly with genetic entropy. It also explains why the mortality rates went down, and it also helps to explain why the strain went extinct. So is that not genetic entropy in real time? Would you accept that as evidence or no? And if no, why not? Go ahead.
Again, I'll have to investigate the circumstances of what caused it to go extinct.
Okay, good.
Again, I'm not too sure if it's maybe the host environment, the human, if maybe humans found a way to combat the virus and then it went extinct that way.
Well, it
but
looks.
I'm not too sure. I'm not sure the exact consequences that caused it to go extinct.
Well, it looks like the codon bias declined consistently over time. That wouldn't be consistent with adaptive evolution as far as I'm concerned. And it shows clearly that they got worse, so not better, at interacting with human DNA. Now that correlates to slower replication, and that also means less lethal infection. So the viruses became less lethal because why? Well, they got worse, not better, as I stated, which is exactly what we would predict. At doing their one and only job, which is replicating themselves. So short generation times, high mutation rate. It's been studied, very technical paper, peer reviewed, I believe, in the NIH journals. I'll send you the paper, okay, because it sounds like you are genuinely interested. I'd like to see your feedback. But that seems to be genetic entropy in real time. So if all turns out well after you read the paper, would that be sufficient for you to validate the genetic entropy thesis? Go ahead.
Sure. Again, if I do read the paper and I find that it seems that the virus itself was getting weaker instead of the human immune system getting stronger against it, then sure, then it should count as genetic entropy.
If all turns out well after you read the paper, would that be sufficient for you to validate the genetic entropy thesis? Go ahead.
Sure, then it should count as genetic entropy.
This is in regards to the debate that just occurred between IP and G-Man. G-Man didn't address any of the questions of his opening, so I intend to do that now. The challenge. The first one is, why is Abraham called an old man if he died much younger than his ancient ancestors and lived much less than his son Isaac? Well, he didn't live much less than his son Isaac. He only died 5 years younger, so not a big stretch. The main reason that they would have called him an old man is because in terms of the age when he did live, which was 2,000 years after Adam's son Seth was born, he was an old man for that age. They weren't comparing him to an old group of people that were living for hundreds and hundreds of years, because he wasn't living among those people that were living for hundreds and hundreds of years. Nearly all of the old ancient patriarchs were dead. Only a handful would have ever existed, so they were the exception, not the rule. Think about it like this. If I was alive in the 50s, and old age was 55 and the age when most people are dying, then obviously, if I'm 55, I'm an old man. And people would be calling me an old man. But is 55 old today? No. Matter of fact, old people today are like 80, and we call them old. So it's just relevant in the time period that person is living. Now, if there's a rare hermit living in the mountains that's 500 years old today, we would still consider somebody 80 old. We wouldn't compare him to that old man, the rare dwindling exception. Number 2, why is Abraham laughing at the prospect of having a child at the age of 100? Well, it wasn't because he was laughing at the age of being 100, it was because he was laughing because his wife Sarah was barren. She wasn't able to have children, so he thought it was a ridiculous concept to even have a children, not because of their age, but because of her inability to have children. Number 3, Jacob allegedly fathered children in his 90s, and that was not considered miraculous. Exactly, just like it wouldn't have been miraculous for Abraham to have one either at that age if his wife wasn't barren. It goes back to that. Number 4, why do dates vary between different manuscript traditions? Good question. They do that because of a variety of different reasons. One of the main ones, and the one to make the most clear, is the ages of Lamech. And the reason why is because he was the patriarch of the genealogy of Jesus, mentioned in Luke 3:36. So his ages were changed so that they would not make prophecy, proving that Jesus was the Messiah. So his dates were changed specifically and deliberately for that reason. We also have the Maccabees during the rendition of the temple in Jerusalem in 146 BC. When they interpreted scripture, they believed that the 144,000 were set in a particular lineage, and that everyone born in that lineage immediately made the group of the 144,000. Unfortunately, according to their theory and math, Isaac was the last of that lineage to die, making him the last of 144,000. But they wanted to be included themselves, so what they did is they altered some of these ages and dates around, making it so that they could fit in themselves. Number 5. Why does the cultural context suggest numbers were used for symbolic purposes? Well, some numbers are, some numbers aren't. The entire Bible has all kinds of symbolic messages throughout it. Some are literal numbers, some are not. You have to distinguish and determine which kinds are. But no satisfactory key to the theological meaning of the ages in the Bible and numbers of any of the patriarchs has resulted in any results whatsoever. So far, they've tried everything. The first theory was that perhaps these numbers are used as an exact multiple of 5. Unfortunately, 4 of the patriarchs don't align with this theory whatsoever. So far, the experts have no answer to this riddle. The Sumerian kings list is actually the biblical patriarchs, and I can prove this to you. Let's take a look inside the Sumerian kings list at Alulim, and he is the biblical Enosh, and it says that he reigned and ruled as a king for 28,800 years. Divide that by 60 and you get 480 years, the actual years of his reign. Also note that if Adam and Noah are dropped from the biblical list, the numbers of people in the two lists are the same, 8. And also the total of durations of their kingdoms and the total ages of the patriarchs are numerically related and are equivalent of the same base number of the Sumerians list, proving that the Sumerians king list is the list of the biblical patriarchs, just with Adam and Noah removed. The only difference is the mathematical system used to date their ages. Number 6. Why do special formulas and symbolic numbers frequently show up in the text? Well, that's the magic of ancient Hebrew. Supposedly, primitive man created this mathematical, linguistic powerhouse of a language that has inside of it amazing features. So asking why there's special symbolic features and formulas inside the Bible, it's to make it cryptic so that you may search out the matter yourself.